In these problems, we're being given a piecewise function. This one has two chunks. And we're being asked to try to fill in a constant that would make the whole thing continuous. Maybe if I draw a picture, this will help explain what this is all about. So you'll notice this function is divided into two pieces. We have where x is less than or equal to -1, it's this quadratic. So maybe that would look something like this. And then where x is greater than 1, it's a linear function. So maybe it looks like this or like that. Those would not be continuous. What we would want for a continuous function is for it to pick up right there. So that's what we're trying to do. So this magic point is the point -1 here, and that's what we need to figure out. We need to figure out what is the value of this first function at the value of -1, at x equals -1. And then if we can make sure that this function satisfies that same thing, then we'll know the function is continuous. So let's try that. Let's plug in -1 here. So that's -1 minus 2 quantity squared. That's going to be a +9. -3 squared is +9. So what we want to do is have a constant here such that at -1, this whole expression equals 9. The value of that function is 9. So I'm going to write this replacing x with -1, leaving the constant as k. That's what we want to solve for, writing the whole rest of the expression, and then that's got to equal 9. The values of the functions have to be the same there. So -1 times -2 is k times -1 minus 2. Let's add 2, and we've got 11 then over here. And then we've got -1 times k is -k. So if -k equals a +11, we can multiply both sides by -1. We've got +k equals -11. So if we have -11 here, that means this function will be continuous and it'll connect right there. So our answer, -11. Let's try one more like that. Okay, so this is, well, this time we have a quadratic function on top, and this one's got the constant in it. And then we've got actually a rational function on the bottom. The point of interest here is 2. So something is happening where things are greater than 2. I don't know what with this rational function. Maybe it looks like that. And then there's something that's happening when x is less than 2. That looks more like a quadratic. And what we want is for them to have the same value at that point. What I'm going to do is evaluate this function without the constant first at 2. And that's just 2 over 2 if you plug 2 in for x. So that's a value of 1. So we want k times x squared minus 3 to equal 1. And x is where we're evaluating this at 2. So 2 squared is 4. So this is 4k minus 3 equals 1. And we can add 3 to both sides. So 4k equals 4. So k is actually going to equal 1 here. So that's a little bit of work with trying to make a piecewise function continuous.